This is Ship It with Justin Garrison and Autumn Nash, a podcast about everything that happens after Git Push. Ship It is brought to you by Fly.io, the home of changelog.com. Launch your apps close to your users all around the world. Learn how at Fly.io.
Welcome to Ship It. This is Autumn Nash, and I'm here with Justin.
How's it going, Autumn?
Hi. Okay, so this week we're going to talk with Kyle Quest about small containers. Do you want to give a little intro to that, Justin?
Well, I mean, minimal containers, DockerSlim, all sorts of things of just like how to make a container small and why it's important is a good topic, I thought. And for people that are running containers, which is a lot of people these days, whether it's in Kubernetes, in the cloud, on-prem, on your laptop, whatever, small is pretty powerful. And Kyle has been around for a while as the creator of DockerSlim and various other tools. So it sounds really cool. We already did the interview and I want everyone else to hear it to see why it's important and kind of how it's different than some different solutions.
I really love that it impacted areas that you wouldn't necessarily think of when it comes to small containers, you don't really think about how much that, you think about it'll make start time faster and all that good stuff, but not or the pull time, I think, but you don't really think about how it impacts security. And I thought that was the coolest part, that it really impacts the way, for one, that you think about doing security, and then the way that you are making a more secure application because you're starting off with a more secure image, that's really cool.
It also made me think about why isn't this a thing for other packaging tools?
I kind of think it should be. It makes you think of differently about creating packages or where you start, where your starting point is, because that's how you have less tech debt. You know what I mean?
Even in all my years, I've never seen a minimization tool for deb packages or jars or things that are here's my thing to run and I give it to someone else. I've never seen anything like that for how do we make this slimmer. But containers, it was because it's a Linux distro and because it's a file system, we kind of know how to take some of that stuff out. And why would it be important to do that? And what other benefits can we get? And so that's really interesting that it's only a container problem or a container solution space.
Well, even the process of taking things out, just the thought of can we build with less? Because there's less to go wrong. There's less to debug and there's less security risks. And that, I think that idea alone, you could run with that, in a lot of different aspects.
Yeah. And we even talked to Kyle a little bit about how much is too minimal, right? Because you want less, but then at the same time, you need to be able to debug something and you want a little bit of tools there or a little bit of access to be able to say actually, I don't want nothing. I want enough that I can figure out what's going on because things will break. And our outro for today's show is all about things breaking. So we're going to tie it all together today.
I honestly think just the conversation of building with less and what do you actually need and giving people the education of you could do this with this, or you could do it with less, or this is something that we do need and this will make it easier for you to build with less. Maybe that's how we do get to building more securely from the beginning, and using less. Let's get into links for the week. I'll go first. How layoffs affected women in tech.
That's the slug, right? But what's the actual title, which I think is more...
Okay, so how the tech industry broke its promise to women. The title is actually better than the link title, but I think it's really interesting because we dumped so much money into diversity. There were so many diversity programs, and it's crazy. This is not something that is just warm and fuzzy. This is something that Harvard Business has done studies on over and over again. It says that you will get a better return on investment. You'll make better software. You'll have better teams and that they'll innovate faster. And this is all stuff that Forbes, Harvard Business, all these huge names in finance and business and how to build a business that are, very well known have told us this is going to add more value to your business. And just the amount of wealth that is going to happen in the wealth transfer to women over the next couple of years, economics are saying that it might be one of the biggest wealth transfers in history, right? And we're like, but we don't need 51% of the like population. Like, we don't need their inputs. And it's crazy because women actually, I think we dictate 71 to 80% of spending, and we influence like that much spending. And I think 70 something percent, 72 or 76% of discretionary spending. So think about it. When these companies are selling products to people, you have like, you know, one person who does a lot of the family and like spending, right? Or, you know, just in general is your customer. And you are not taking in their perspective to what kind of products are they looking for? What kind of testing should you be doing? And we not only sold women, hey, come be in tech, we need you. And then we were like, just kidding, because, you know, money is an issue and we're in a tech recession. So we no longer are interested in diversity. So what does that like mean for tech? You know, like what does that mean for how we build software and our return on investment if we have this thing that statistically shows we are not going to build as good of software and, you know, have as good of a return on investment without having people from different backgrounds, especially women, who is going to be like a majority of your audience and like the purchasing power. And then we've decided to just abandon that. Like, where do we go forward? Also, retention is horrible. It's like 56% by mid-career by 35. So like, not only is only 25% or 27% of the industry women, and that's not even mostly technical. Like a lot, I think Black women are 1.6%, Latino women are like 2%, and those are like not widely like engineering, right?
Yeah, in tech is a very broad term for management, PM, various things.
Exactly. And it's a proven fact that most are not like holding engineer jobs, which is terrible. I don't think I've ever met a real Black female engineer in real life. I think I know 2 on Twitter, you know, and 2 engineer managers.
One sec too, like call out to any women in tech right now. If you would like to come on the show and you run infrastructure, we would love to talk to you.
We can't only interview dudes. Like, please come. I would love to talk to you and talk about shared experiences. But also, like, if you cut that number by 56%, like, what are we like left with? 0.3? You know, like that is horrible.
Diversity isn't, or in multiple voices, this isn't only a problem when stock prices are going up. When stock price goes down, when it flattens out, all of those things, it's still a problem. And we can't just ignore it or throw it like, hey, you know what, that process and that thing we were doing, like, never mind anymore. And even all of the benefits that aren't even directly targeting for women or diverse people that don't have tech backgrounds, like work from home is a big thing where it's like, hey, guess what? The flexibility you get to work from home basically went out the window as soon as big companies decided.
And think about it. How many women, 75% of women are caregivers, either to like elderly people or to children, right? 91% of military spouses are women. All of this, like, I think people think of warm and fuzzy, like diversity is what you do when like things are good and like to make you feel better. No, it gravely affects your bottom line. And the fact that you think about when we had the camera that didn't even see people that were different. You know what I mean?
I remember
Think about
that.
like, I mean, come on now. Like, it not only are you not getting the return on investment you get, you now have to scrap projects and start over. Like, we've had racist Twitter bots. We've had all these different things that have shown us, hey guys, we need to do more testing. We need to have more people in the room to have like more opinions. And now we want to put AI and data in everything when the main component to fighting data bias, which is diversity and diverse opinions, we're getting rid of diversity. Like, is that not scary? Because I love AI and I love data, but what are we doing to make sure it's good for everybody?
Well, Autumn, it's almost like you should give a conference talk about this.
I know.
when you're listening to this podcast, it's Autumn is probably on stage giving this talk at the Southern California Linux Expo. So if you want to catch the recording, they will be up on YouTube. There are live streams if you can't make it in person, but if you are there in person, we're both going to be at scale, and we're actually might be doing some recordings in person if we can make it work.
I want to talk to all the people. I'm so excited. Also, like, I'm such a data nerd and I like love this stuff. So like, I'm so excited to give a talk about the things I rant to my friends about. And they're probably like, is she ever going to shut up? And I'm just like, I'm going to tell everybody that. So
you'll have a room full of people and they want to be there. They want to hear more. It's going to be great.
I'm so excited. What's your talk going to be about, Justin?
My talk at scale is about, of course, Kubernetes and on-prem actually, and data centers, because I love hardware and I think data centers are still very much a good option in the year 2024.
I'm so sad that I'm going to miss like some of your talk. Like, I'm going to be like literally getting from the airport to scale.
Yeah, it's all right. We're still going to meet up. It's still recorded. If anyone wants to live stream it, or if you're there in person, come find us. I'll be around Thursday, Friday, Saturday, and Sunday because I help organize Scale and KCD. And then Autumn, you'll be there mostly Saturday and Sunday, but a bit on Friday.
And we're getting tacos, so everybody, let's meet up and get tacos. I'm so excited. We're going to finally meet in real life.
I know.
Also, we have to not forget to talk about your link. What's your link for this week?
My link is all about the Fediverse, actually, for Mastodon specifically. I found this link interesting mainly because it talks about how to kind of discover infrastructure and how to discover what the backend of something is. So if you're not aware, Mastodon is a server that connects into Fediverse instance with ActivityPub, and someone walked through how they were figuring out where the instances were running and what providers they were on, because all of these ActivityPub endpoints have well-known endpoints. And one of the things at the very beginning was about 50% of it is on, or at least fronted by Fastly and Cloudflare.
Oh, wow.
And they're like, okay, Fastly and Cloudflare, a lot of people cache it. It's like, that's fine. That's probably a normal thing if we're just looking at the front end. But they actually go through the effort of like, hey, let's make those servers talk to us. What if we make a call to one of their endpoints that make them reach out to us? Because then the backend has to do it. And then they can find out where that backend is stored. And so they actually do that. And one of the coolest things in here was there was a good percentage of anything behind Cloudflare, because Cloudflare was the largest CDN in France. But 30% of the Cloudflare endpoints were hosted at home. For BGP tools, it just showed it as a home internet access point. So like people are running Mastodon servers at their house, putting Cloudflare in front of it so that they don't get DDoSed. Which is a German cloud provider, 51% was there, mostly because of Mastodon.social, which is the big instance. It's like the largest default instance.
That's so cool. I wouldn't think Germany.
Yeah, Herstner is a really good, cheap provider. And there are some other Mastodon hosting services that are like, hey, you can give us $5 a month and we'll run the Mastodon instance for you. And I think most of those do use Herstner just because of the really low, basically VM cost for it every month.
Do you still use Mastodon? I feel like I haven't used it as much.
No, I don't.
I feel like I'm more on Twitter and Blue Sky.
Yeah, I've moved most of my effort over to Blue Sky. And the reason I actually wanted to bring up this link this week, because we will have people from Blue Sky and Mastodon in the future talking about different instances they run.
I'm so excited to talk to Paul, so excited.
Yeah, Paul's going to be great. I'm still trying to get Jacob from Blue Sky. And then we have someone from the Mastodon instance, Hachyderm, which is a really large tech-focused Mastodon instance. And so we're working on schedules for all those.
They do such a good job at Hachyderm, they really do.
Yeah, so I'm excited about that coming in the future. But right now I was just kind of looking at, where are people running this stuff? And I know Hachyderm runs mostly in an on-prem environment, but is fronted by Cloudflare. So seeing how people are doing this is cool.
I love the way that you approach infrastructure in a very physical, cool way where you get excited about it. Then you talk about it in means to actual projects and the way that it kind of interacts with the real world, because I think it makes it so much more accessible to people that want to get into that, your approach is so much more accessible, and you don't talk about it in a way that is so high level that makes it intimidating. You talk about it, how it affects the real world, which makes it so much more accessible to somebody that wants to learn about it, which is how I think we get more people into tech and more people into infrastructure, because the percentage of people that can, meet people at these high level places, it makes it so hard. So I think that's just a really cool, way to be, and helpful to let other people in and kind of get people interested, which I hope that's what this podcast does. It makes infrastructure more accessible and obtainable and not as intimidating,
Yeah, and I mean, I appreciate it because that's how I understand things and that's how I learn things. If I'm going to try to figure out how does security work, I need to be able to relate it to something that I physically know.
Yes, I'm I need that I need to draw that relationship,
I also like to do it in entertaining ways. I recently started a series on my TikTok channel about acting out different technologies, and people seem to like it because
oh my god, I'm so excited.
a lot of them, I have a handful of them out, and the very first one got over 1 million views, and I'm like, oh, this doesn't usually happen. And so I just started doing it, and it's been really fun because it's you can get creative. And
when
also,
are you going to help me with my TikTok? Because I just stand there and look awkward. I'm like, oh God, I can see myself.
It is intimidating for sure. And you're just like looking at yourself and then you're looking at all of your own flaws or whatever. And yeah.
I know. And can we talk about like the teenagers are so much cooler? They're like dancing and I'm just like, I'm too old for this.
Before we go to the interview, I have to say, like, someone left a comment on Reddit on a blog post, and there was a comment, and they called me.
Wait. By the way, guys, you can't see it, but he's making his excited Justin face, and it makes my entire life, like, his eyes light up, and he gets like excited, and it's like the best. Okay, go.
But I was embarrassed because they left a comment and they called me a Chad, and I was like, I don't know what a Chad is.
Oh no, they did not call you a Chad. No, they didn't.
I had to look it up. I'm like, okay, it's a good thing. Thanks. Like that was.
That is not a good thing.
No, there was. I looked. Okay, maybe it wasn't. I said thanks because I didn't know for sure.
Being a Chad is not a good. How dare they?
Okay, so maybe I'm wrong. I'm just too old for this.
I would like to vouch for Justin, and he is not a Chad, y'all. He's not a Chad.
So the one definition I saw says you're either extremely good or extremely bad, and the comment was related to being a Chad in a room of disappointment. And I don't know. I think it was a good thing.
Okay.
Maybe so like everyone else was bad. I don't know. Maybe I'm just too old.
I feel like when it's like Chads for like dating, you're just like, oh, you don't want to be a Chad. But maybe it was a good Chad.
I don't know. It's a gaming thing, I think. At least all the definitions I saw. And some of them were like, Chad is awesome.
Guys, This is how you know we're old when we have to look on Reddit to figure out what people are calling us.
I don't know what they're saying.
Oh my God. Does that mean we're old?
If someone could break it down into terms I will understand as someone from the 80s and 90s.
Comment in the comment section if you can explain Chad to people in their like 30s.
I am 40, okay? I definitely need these explanations.
I was trying to help you out and bring you to 35 with me, okay? Like,
I appreciate it, but all the gray's showing. It doesn't matter. It's just like if anyone watched these clips, they know I got gray in my beard, my hair.
Also, if you invite Justin to any states that are under 50 degrees, he will freeze.
I have 3 jackets on. It is okay. I will survive. I just need a few more layers. All right, so let's go ahead and jump into that interview with Kyle right after the break.
Well, friends, I have some good news for you. It is launch week once again for Sentry, and I'm here with Rahul Chabria from the product team at Sentry. So, Rahul, what can you tell me about the launch week this year for Sentry?
In March, we're making a huge investment into our product platform. We're trying to make it faster, better. In November, we shared a sneak peek about our new metrics offering. So now developers will be able to define custom metrics they care about and monitor how quickly their app is responding to the business measures they have to be accountable for, plus also like the customer experiences that they've committed to. And that's going to be available in an alpha. People can sign up to get access. We'll turn it on for them like within a couple of days once they write in, and they can get going right away. Now, on top of that, it's like we are looking more at how do we make the product smarter. Now, I know the world is talking about AI and ML, and they're all solving like, we think like entertaining problems, but Sentry's taking a more thoughtful approach to it. We are trying to look at what is the developer trying to do? Like our goal is not to have you sit in Sentry all day long. Our goal is not have this like be a tab that you need to keep open. Our goal is to have this be a tab you open when something is wrong, give you the information you need right away, tell you how impactful it is to your user base and if you should care. And if it is something you should care about, here's how to fix it. So we're taking a broader look at how developers use the product. Where is the noise they're seeing? Like, are they seeing repeat events? Are they seeing like things that are not critical rise to the top and have to automatically resolve them or ignore them? So we're going to make Sentry a little bit smarter with artificial intelligence to give you a more prioritized view of the issues that really matter so you can solve them quickly and move on and not be distracted by random rage clicks that are, just ghost issues. Those are the two major things coming out. It's like thinking about more like defining the metrics you care about, also figuring out ways to like organize your issues so developers can actually solve those problems faster. And then we're also working on a few features for our mobile developers. Like Sentry is a platform that works with any technology you want. But for mobile developers, there's always been this like, wait a second, there was an error, but hold on, let me go dig up this device and see if I can recreate it. I can't recreate it. Okay, let me go look at the stack trace and like it's definitely something there. I'll just fix it and push a release and hopefully those now like the crash rates go up. up and the crash for user rates go up. But it's always like this idea, like I still need to figure out like where's that bank of used old devices for someone running, iOS 13 on an iPhone 11 somewhere. So we're giving them the ability, we're previewing the ability for mobile developers to actually see what happens on an end user session. So that way there's no question about the problem or the latency issue, and building out more performance capabilities so they can see exactly how fast their app is performing. Those are the three big things we're planning on talking about, aside from core platform announcements, some integrations and cool partnerships we're working with. Yes, the big investment in machine learning and artificial intelligence.
Okay, Sentry's launch week happens March 18th through the 22nd. Check the show notes for a link to the launch week page. They'll be showing off new features, products. You can tune into their YouTube channel or Discord daily at 9 a.m. Pacific Standard Time to hear the latest scoop. Or if you want to get swag along the way, enter your email address at the page. We'll link up to get swag all along the way. Or join the Discord. Whatever works for you. Head to sentry.io. That's SENTRY.io. I'm sure they'll link it up somewhere. Or check the show notes for a link. While you're at it, use the code CHANGELOG to get $100 off the team plan. Again, use the code CHANGELOG. Go to sentry.io.
All right, really happy to have Kyle Quest on the show. Kyle was a founder at Slim AI and DockerSlim, and has a lot to say about Docker containers and how to make them smaller, but also how to make them more useful. So Kyle, welcome to the show, and can you tell us about yourself?
Sure, good to be here. Yeah, like you said, I created DockerSlim. It happened a few years back. I did it during a Docker hackathon, one of those global hackathons. I had a problem, and the team I worked with had a problem delivering production-ready containers, and I figured there has to be an easier way to do it, and that's how it happened. DockerSlim allowed me to create production-ready containers without changing the tools I used and without changing the workflow I had. So I had those, fat Ubuntu images, but I still got really, really small images, hardened, and all of that. So I got the outcomes without making all of those changes. And then later on, Slim AI was founded to take advantage of some of those concepts. And now I'm actually exploring a new venture that combines the application intelligence concepts from DockerSlim and combines them with the new automation opportunities that emerged in the last year plus in tech. Everybody knows about. I'm not going to go into that, but solved my own problem, worked great. Others liked it, and since then, more and more people benefit from it.
I think you should go into like the things that you feel are the new automation opportunities, because you never know what you may know or think that like is common knowledge that maybe isn't common knowledge. So like, what is the new automation opportunities that you feel are out there that changed your mind to want to pursue this new venture?
Sure. So with, I mentioned application intelligence, and the idea, one of the core concepts with DockerSlim was this application-centric approach as opposed to the infrastructure-centric approach with most of the cloud-native tools. You take Terraform, for example, or other tools. They help you interact with the infrastructure, but they are application agnostic. So what happens with those tools? And it's not Terraform specific. It's just an example. You have to program those tools with the application knowledge. So you build the configurations and all of that. And it's a very manual process, and it requires a lot of domain knowledge. So this is where the application-centric approach comes in and application intelligence comes in. You capture the information about the application, and once you capture it, you can automate the activities you had to deal with manually that required a lot of domain knowledge as well. For example, not everybody is a container expert. Not everybody understands the magic with layers, caching, and security, and all of that. So you have this problem where you have a lot of manual work and a lot of domain knowledge. Capturing the information about the application solves the first step of the problem, but then you need to automate what you do and use the information that's collected. Originally, the automation opportunities were pretty basic. You kind of had to hard code it the old school way, but now with but the new generative AI advancements and the autonomous agent capabilities, you can take that application knowledge and you can automate the activities associated with the infrastructure and the application. That's where I'm trying to focus now.
That's really interesting. I love that it came from a hackathon, like the original idea. That's so exciting because I'm like a huge proponent for like hackathons and giving people the opportunity to be exposed to like new technology and be able to build and solve for real world problems, because I think it's really good experience.
And it's always good to solve your own problem.
Yeah, and that hackathon to project to product is a really cool cycle just to kind of explore. And I was going to point out, like, Slim AI was I think one of the first domains I ever saw that had the .ai. You were doing .ai domains before they were cool. And
so the reason AI was there is not because of the actual artificial intelligence. It represented two concepts that one I mentioned, application intelligence. And then the other one is autonomous infrastructure. So the idea was application intelligence leads to autonomous infrastructure, but we never got around to that. And that's what I'm trying to do now, take the application intelligence and get to autonomous infrastructure.
So the original problem you were solving, though, was, I don't assume it was just my containers are too big. There had to be something that was driving that. Like my very first container that I ever built was 60 gigs, and it was large, but it was still useful. And so what problem actually drove you to like, why did you need a small container?
But production ready containers or VMs or anything, when you prepare your application for production, you go through this hardening phase where you go from a developer-friendly setup, either a VM or a container, to a more locked down setup where you look at the security to make sure it can be easily exploited. For example, when an attacker exploits a vulnerability, they persist and then they move laterally. So one of the goals with hardening, manual or either way, is to mitigate those activities. If there is an exploit, you try to mitigate the persistence of it, or you try to mitigate the lateral movement. That way, you limit the blast radius. So that's one of the classic things you have to do. But again, now you have to be a security expert, and it's a very manual process. You might get lucky and have a hardening script that you run, but that actually ties you to a specific OS with a specific version. And that's related to the idea of small container images and minimal container images and other alternative solutions that will be good to explore compared to what you get with DockerSlim, or later on it was called Slim Toolkit, and now it's evolving into Min Toolkit. Min stands for minification. And the reason why it's evolving to the new name is because when the tool was going through the sandbox process in CNCF, they didn't like the name and they asked for the name to be changed, but I couldn't change the name right away. And now I'm just getting to it. So now there's a new name, but the idea is the same. You keep everything you have. For example, if you use whatever base image, you keep it and you get the small images. And you get to keep your hardening script. So if you run additional things there, you won't have a problem. But if you try to change your base image, you might get lucky, or you might end up with a lot of work. So that'd be good to explore as well.
And how does it actually work? Like, how did the original hackathon DockerSlim work? And is it still working mostly or similarly today through all these cycles and productization and name changes?
So the open source project worked pretty close to what it is now. It's just added a more advanced capabilities and added adjacent capabilities. For example, one of the adjacent capabilities is the X-ray command that helps you understand what's in your container images. So that way you can see what's inside, and then you can make sense of them. It's super useful, and you get a lot of insights that you normally wouldn't get. And then the other adjacent capability also related to visibility is linting. And there are a lot of linting tools, but it is complementary to the X-ray visibility. And one of the newer capabilities is debugging. So you create a minimal container image, but it doesn't have a shell. And then you want to use that minimal container image in production. And I heard this over and over again when I talk to people about it, the developers, DevOps engineers, SREs. They say, okay, how am I supposed to debug it? There's no shell. What if it crashes? I mean, if the application is perfect, great. It never crashes. It has no problems, but it never happens. It doesn't work that way. So not being able to debug minimal container images has been a barrier to adoption for the minimal container images in general, regardless of how you build them, whether you build them from scratch, doing it manually or using tools. You got to be able to debug them. And that's one of those additional adjacent commands. In terms of the core capability, minification core capability, the intelligence to handle more advanced applications, runtimes evolved and improved. But the main idea is to combine static analysis with dynamic analysis and build this profile in terms of what it is that you have, what it needs, the dependencies, and all of that.
You have these extra abilities on top of like slimming things down. You have we need to just remove or give you best practices around your Docker file to make sure your cache is good. And we can get rid of all that apt or yum cache or whatever it is that you don't need anymore for your application. But there's got to be like a middle thing here of like, I do from Ubuntu and my application is a Python script. And are you profiling the application as it starts and then saying, hey, here's all the files you opened. Let's delete everything else. Or are you compressing files, or are you just relayering the container images so polls are faster? What is the actual technology that allows you to make this from a few hundred megs to down to tens of megs, hopefully?
So it's a combination of several different things. The origin of this is the security tech I've used in the past because I've been involved in security for more than a couple of decades. I've been wearing a whole bunch of different hats, a builder, a breaker, a defender. It used to be my job at Microsoft to break Windows, for example.
The software, not the physical buildings.
Yes, the software. Yeah, exactly.
You still fit in a dad joke.
It was right there. I couldn't not take that one.
It was fun, and it is fun. So I had a lot of background in tech in terms of what was used, and a lot of the tech in security is about catching the bad guys, catching malware. So I thought, well, why not leverage the same tech and repurpose it? Instead of trying to catch the bad stuff, why not use it to discover the good stuff? So I repurposed the security technology that's available in the Linux kernel for the most part. For example, one of the capabilities DockerSlim uses is this FA notify capability in the Linux kernel. So that was created for the antivirus software. So the antivirus software on Linux hooks into this interface, and then it sees when applications run, they access files, they write to files. So that was one of the capabilities it leveraged. Then it leveraged ptrace. That's used by debuggers. So whenever you're debugging something, you're using ptrace. So that it used that as a capability. And then one of the newer capabilities is based on eBPF that allows you to observe what's going on in the system.
What's eBPF?
So that's a good question. So eBPF is an evolution of the old school concept behind BPF, Berkeley packet filters. And it was a networking construct that allowed you to capture packets from the network and allowed you to filter packets that you're capturing. So a couple of decades ago, network sniffing tools and networking tools have been super popular. They're still popular, but I was involved in that space a lot. So all those tools used eBPF to capture packets. But then the new version was created that allowed you to capture not only the network traffic, but other things in the system. And E stands for extended BPF. So with that extended eBPF system, you can get the networking information. You can hook into different parts of the networking stack, but also hook into different parts of the OS stack as well, including the parts that allow you to see what's going on in the system. And now it's used by a lot of different tools, security tools. A lot of the runtime security tools use that, especially in Kubernetes. And then a lot of continuous profiling tools are using it. Observability, if in the last couple of KubeCons, continuous profiling and observability powered by eBPF have been big themes, and it's growing in popularity. And there's also a number of tools, security tools like Falco, Tetragon, Tracy that leverage this capability for runtime security needs in Kubernetes clusters or endpoints. And that's one of the new tools that DockerSlim or Mint Toolkit is integrating with in order to get more data to use for application intelligence.
What was like the coolest thing that you got to break when you were at Microsoft?
One of the coolest things I liked at Microsoft that our team had was the fuzzing setup. So with fuzzing, what you have an application that generates input for the target application. And that input is meant to trigger unexpected behavior and crash the target application.
It sounds like so much fun.
And Microsoft had and still has this awesome setup where it would observe the target application and it would adjust the input that was generated based on the bytecode coverage in the application in order to get to different parts of the application. And that allowed that fuzzer to break a lot more things and find bugs that you wouldn't normally find. And this is actually a source of one of the ideas that I'll be working on as well in terms of automating container-related activities, testing containers, because testing is a common problem. Nobody has enough tests for their applications. Everybody knows that you're supposed to test your applications. Maybe some people have their unit tests, some people have integration tests, some people have end-to-end tests, but you never have enough. And that's one of the things that's useful to have when you're trying to understand what the application is doing, and leveraging this fuzzing magic and fuzzing technology is an opportunity to unlock some of those automation opportunities. So the fuzzing tech was great. I think it was the best compared to other vendors, and it's been a while, more than 10 years, but they were ahead. Microsoft was ahead of Apple, and I'm pretty sure it was ahead of Google in terms of that tech because they had a head start there, but maybe other vendors caught up.
Microsoft seems to do security well. I love the working backwards of security where it's like, let's go break some stuff, and then we're going to figure out from breaking some stuff how to build really good secure software. Like, it's probably like one of the most exciting of working backwards in software. So it's pretty cool.
So you have all of these technologies. You have, as part of like slimming this down, FA Notify, you're basically looking at when you start the process, what does it access? What does it do? Anything that's not in that list, let's get rid of it, right? Like, let's just like throw it away.
Almost. What it is, it's one of the sources for data. So each different monitor type collects different types of telemetry, provides different information. And then there's additional processing. For example, let's say the FA Notify monitor saw that one of the Python object files was loaded. And the way it works with Python applications, the Python runtime, it compiles the Python application into bytecode. So you end up with these Python object files that are cached. And when the application runs, it loads the object file. So what you see loaded is actually the object file, but you still need to have the source file. And that's an example of additional processing that needs to happen. So you see the object files being loaded. You see that, it's the Python runtime. We need to have the source files as well. So the source files are also added. And so there's a number of additional post-processing steps that collect additional data based on the application type, based on what's going on. So it's not just what's loaded from a FA notifier. There's a lot more going on there. Plus, let's say you load an application, I don't know, kubectl. Now, kubectl is a binary, well, any other binary, ping, for example. It's an ELF binary that has, most likely, it has dynamic dependencies. It has shared libraries that it loads there. So one of the other additional post-processing steps and an example of static analysis is identifying that the file you have is an ELF binary, understanding the kind of imports and the dynamic loads it does, and then finding those dynamic shared libraries and fetching them as well, and then doing it recursively. So there are multiple layers of processing and post-processing to combine all of that application-related data into this one complete manifest.
That, I think, brings up that application intelligence piece of it, right? Because like if I just take all the PyC compiled Python and then like stick them somewhere else, I'm still going to have a bad day when I try to run it and do something with it.
Yep.
But a lot of what you've been talking about is security related, specifically for like, hey, we want minimal for security. What other benefits? Like I remember when I was looking at DockerSlim, it was just like, oh, your polls will be faster, or oh, your disk space will be less, or even like, let's optimize this so we can share layers between containers a little easier. What are the other things outside of security that are like, hey, this is something that you might want to do because of something else?
So let's start with security either way, because there are interesting benefits there that you normally wouldn't get otherwise, or you would have to do a lot more. So with security, you're removing the attack surface that you have in your container. The concept of attack surface is one of those fundamental constructs in security. The more stuff you have, the bigger attack surface you have. And with DockerSlim, you automatically reduce the attack surface. And not only that, the way you do it in a proactive way, not in a reactive way. If you use the traditional security controls like vulnerability management, the way it works, it's a very reactive control. Somebody discovers a vulnerability, then that vulnerability is recorded. Then scanners look for that vulnerability. Then you try to fix or remove that vulnerability. It's very reactive, and you secure your application only after the fact. With the DockerSlim approach and the proactive attack surface reduction, you're removing a whole bunch of stuff that may be exploited in the future before there is a CVE discovered and before the scanners know about it. So that's one of the benefits, and it makes it easier to do. And it's actually related to container best practices that will be good to talk about.
Honestly, that's really good best practices for all software, right? Having the least amount of attack area. And just the fact of like having less dependencies and stuff, like it can really help you, but people don't think of it like in advance, you know? You now take on all the security risks of every dependency that you pull in, and even if there's like half the time we have packages that we don't even use, you know, and they're just sitting there waiting to make your application more vulnerable, you know, and you don't even need them.
Exactly.
It turns out it's hard for people to understand that, right? Like that's a really difficult thing to say, like, hey, I want you to go through and tell me which files we need or not. Like, I'm not.
Well, and you also need to understand all those files, right? Like we don't all understand what all of those things do. So you're like, well, do I need it? I don't know. Maybe I might need it. You know what I mean? So
exactly. And that's actually related to one of the key constructs behind the container best practices. There they say, only put the things you need in the container. It sounds great in theory, but in practice, there's a disconnect because nobody I've talked to ever put stuff they don't need in containers intentionally, just for the fun of it. You know what? I'm going to put junk in my containers because it's fun. Nobody does that.
A lot of times they just download whatever they can or whatever seems like it's going to fit. I mean, that's kind of like security everywhere. There's so many best practices, but I don't know if for one, security is ignored a lot too. Like, I don't know if people always have the tools to know what they should be leaving out or what, you know? So I think like we always have like good intentions, but a lot of it does not translate to practice. And if we could find a way to bridge that gap to help people to make those good decisions and to be informed in that way, having things like this where it's like the least amount of dependencies and the least amount of files that you can run and be successful with, Like if we built more images and things to like provide the public and kind of educated people more on what they actually need, I wonder if it would make it easier to follow those best practices.
But some of it is also related to application lifecycle, because some of the things you have is application development and debugging related to make it easy to troubleshoot and all of that. So technically you might need it, but you might need it in the early phases of the development process, or maybe potentially later when the application crashes. And that's one of the problems people need to solve as well. How can you have those tools, but not all the time, only when you need them? So creating minimal container images, regardless of whether you do it from scratch, with distroless, DockerSlim, you need to have a story there to complement those minimal container images that allow you to bring in the tools you need when you need them. And that's where the debugging capabilities in Kubernetes, leveraging ephemeral containers and in other runtimes come in. You need to complement those minimal container images where you can say, okay, I'm going to remove those tools in the image, but then I can bring them back later.
And I love that you have debugging, because that's the hardest part of software sometimes. Like writing code to me, I feel like is easy, but the debugging and figuring out what happened can be hard, and especially when you're pulling something new, like if you're new to Dockers, And I wonder also if because you have a minimal image, if that makes debugging easier to figure out where things are coming from also. So maybe that would be a lot of the value also, security and the fact that it's easier to debug and to know where like things are coming from and what's not working.
Yeah, it's definitely a part of it. And, those two things go together. But in terms of other benefits, a couple of other benefits, classic benefits that developers like: faster pools, that's one. And then faster startups, that's another one. So that in some environments, it's a bigger problem than in other environments. Because let's say you use some kind of containerized function environment like Lambda. There you get billed for each load, and Lambdas get loaded a lot. A lot happened with Lambdas in terms of optimizing and different advanced image formats and all of that. But fundamentally, you get charged every time your image gets loaded. And that's one of the benefits that others like too.
How does removing files I don't use increase my startup time?
It makes it faster, but it decreases the time it takes to load the image.
Just because of image pull times, not because of actual application startup.
It's both. So there's the image pull time, that's one. And then there's the actual startup time. I had a benchmark that measured the pull time and the start time individually. For different runtimes, it's different. And for example, one of the adjacent examples and tests I had was with containerized Lambdas. So I had the original fat containerized Lambdas, and it took significantly more time there. And there it's a combination too. So it depends on how you measure it, but there is the pull factor and the startup factor. And depending on the application, the startup time is also different because, again, it takes time to load the file data in memory, to set up the layered FS and all of that magic.
But that's a cold start problem, right? Because that's still a
Yes.
size of cold start, not necessarily application startup. If I have two cached images, one is slim and one is fat, the application is not going to start faster, but the size of the file system in a Lambda cold start situation could cause that as here's a side effect because image pulls faster and we don't load this into memory or even layer this on top because we just have less files.
Yeah.
It's not actual. So what's the difference here with, like, we were mentioning, we can start with Ubuntu and take all the stuff we don't need. What's the opposite approach of, like, why don't we start with scratch? Why don't we start with something that's minimalistic to start and only add the things we do need? A lot of me are just talking about, like, this is best practice for all software. And for Talos Linux, where I work at Sidero, like, we have 12 binaries and that is it. Like, every other operating system has hundreds and hundreds of binaries on the default install. Like, we just start with the one purpose-built thing. We have almost nothing installed on it. And so that's like, we can start from scratch in a container and just say, like, I can go the reverse route. And why trim down instead of build up?
It's that whole working backwards thing where you start.
Exactly. So the biggest problem is that you don't always know what you need. Let's take a Go application as an example. A classic application an application example there you see is a statically compiled Go hello world. It's static. It's a single binary. You take the scratch image, you just copy the binary there, and you're all set. But in the real world Go application, there's a good chance that you need a lot of different things beyond that. Certificates, 1, the time zone information, 2, the user information, 3, and it just keeps piling on. So you keep on discovering that you need a lot more. If you use CGO, you need more stuff, and so on. So it comes down to this. When you control the environment, especially when you have a dedicated operating system like you guys, you know exactly what you need. You control that, and you design that environment to work the way you need to work. But for the general purpose operating systems, for regular application developers, they simply don't know. So one of the things I see with people when they use multi-stage builds, so that's one of the recommendations that you hear. Use multi-stage builds. You build the image in one stage. You run npm install, for example, if you have a node application, or npm CI if you really follow the best practices. And then you copy the stuff from there, from that stage to your release stage. Well, there again, you need to know what to copy. So most of the time, you see people just copying the entire application folder with everything in it. So it's pretty much going with, I'm just copy everything and that's it. And there's a lot of junk there still. And then you can't necessarily have a scratch image in the release stage because you need to have dependencies. So you'll have a minimal release stage image that's great to have. But again, that's the main problem. You don't always know what you need. There's a middle ground. The idea with distroless images.
That's exactly where I wanted to go. I was like, what is the difference here with slimming it down from a fat image versus distroless? And how do those compare?
Yeah, so with the distroless images, you have this minimal foundation for the runtime you have. For example, for node applications, you have a set of basic OS libraries and then a set of runtime specific libraries, Node.js libraries that you need to have. And then you just add your application code on top of it with that multi-stage build, and you're good to go. And that's one way to do it. And it's a middle ground where you can say, okay, I have a foundation that's stable, and then I'm just going to put everything in the application on top of it. But if you want to optimize it even more, then you can use something like DockerSlim, because you can run DockerSlim on the distroless base images. You're not going to get a 10x size change, but you might get 50% change or 30% change. So depending on the environment and how small you need to go, you can still benefit from that. And those distroless base images, they help you with the base image part, but not the application part of it. And if you look at other available options like Wolfie and ChainGuard, they also help you with that foundation, but then you're on your own with the application itself. And you need to have this full end-to-end solution for the end user.
And runtimes are almost operating systems unto themselves because they need to be generic enough so you can run anything within the Java ecosystem or NPM ecosystem and still be able to like, hey, we don't know what's underneath us and we don't know what's above us, but we need to be big enough to cover as much as we think is possible.
Yeah, they're like stem cells. The base images in general, base OS images are like stem cells. They can become anything. Those images can become anything depending on the application. The same with the runtime images. They're a little more purpose-built, but again, they're open in terms of what they're going to do. So they need to have a lot of extra components that you may not need. That's why slimming distroless-based images also works, and you get benefits from 20 to 50% there as well.
Well, thank you so much, Kyle, for coming on and explaining how that works, why you might want small container images, and how it compares DockerSlim versus something like distroless. That's a great example of when you might choose one or both, and some of the benefits around each one.
Yeah, I've learned so much. It was really nice meeting you. It seems like it provides a ton of value with just like the security and, the like faster pulls in general. It's just a lot of value.
Yeah, it helps developers, it helps DevOps engineers, and it helps security engineers. Those are the three personas that I encounter all the time.
If any listeners wanted to find you online or reach out, where's the best place to contact you or talk to you?
Twitter, KCQ on, and LinkedIn, Kyle Quest.
Sounds great. Thank you so much. And we'll be right back with the outro of the show.
What's up, friends? This episode is brought to you by our friends at Synadia. Synadia is helping teams take NAS to the next level via a global, multi-cloud, multi-geo, and extensible service fully managed by Synadia. They take care of all the infrastructure, management, monitoring, and maintenance for you so you can focus on building exceptional distributed applications. And I'm here with VP of Product and Engineering, Byron Ruth. So Byron, in the Nats versus Kafka conversation, I hear a couple different things. One, I hear out there, I hate Kafka with a passion. That's quoted, by the way, on Hacker News. I hear Kafka is dead, long live Kafka. And then I hear Kafka is the default, but I hate it. So what's the deal with Nats versus Kafka?
Yeah, so Kafka is an interesting one. I've personally followed Kafka for quite some time, ever since the LinkedIn days. And I think what they've done in terms of transitioning the landscape to event streaming has been wonderful. I think they definitely were the sort of first to market for persistent data streaming. However, over time, as people have adopted it, they were the first to market. They provided a solution, but you don't know what you don't know in terms of you need this solution, you need this capability, but inevitably there's also all this operational pain and overhead that people have come to associate with Kafka deployments. Based on our experience and what users and customers have come to us with, they would say we are spending a ton of money on spend on a team to maintain our Kafka clusters or, managed services or something like that. The paradigm of how they model topics and how you partition topics and how you scale them is not really in line with what they fundamentally want to do. And that's where Nats can provide, as we refer to it, subject-based addressing, which has a much more granular way of addressing messages, sending messages, subscribing to messages and things like that, which is very different from what Kafka does. And the second that we introduced persistence with our Jetstream subsystem, as we refer to it, a handful of years ago, we literally had a flood of people saying, can I replace my Kafka deployments with this Nats Jetstream alternative? And we've been getting constant inbounds, constant customers asking, hey, can you enlighten us with what Nats can do? And oh, by the way, here's all these other dependencies like Redis and other things and some of our services-based things that we could potentially migrate and evolve over time by adopting Nats as a technology, as a core technology to people's systems and platforms. So this has been largely organic. We never, from day one, with our persistence layer Jetstream, the intention was never to say, we're going to go after Kafka. But because of how we layered the persistence on top of this really nice pub sub core Nats foundation, and then we promoted it and we say, hey, now we have the same semantics, same paradigm with these new primitives that introduce persistence in terms of streams and consumers. The floodgate just opened and everyone was frankly coming to us and wanting to simplify their architecture, reduce costs, operational costs, get all of these other advantages that Nats has to offer that Kafka does not whatsoever, or any of the other similar offerings out there. And you get all these other advantages that Nats has to offer.
So there's someone out there listening to this right now. They're the Kafka cluster admin, the person in charge of this cluster going down or not. They manage the team, they feel the pain, all the things. Give a prescription. What should they do?
What we always recommend is that you can go to the Nats website, download the server, look at the client and model a stream. There's some guides on doing that. We also have Synadia provided basically a packet of resources to inform people, because we get, again, so many inbound requests about how do you compare Nats and Kafka? And we're like, let's actually just put a thing together that can inform people how to compare and contrast them. So we have a link on the website that we can share, and you can basically go get those set of resources. This includes a very lengthy white paper from an outside consultant that did performance benchmarks and stuff like that, and discuss basically the different trade-offs that are made. And they also do a total cost of ownership assessment between people who are organizations running Kafka versus running NATS for comparable workloads.
Well, there you go. You have a prescription. Check for a link in the show notes to those resources. Yesterday's tech is not cutting it. NATS, powered by the global multi-cloud, multi-geo, and extensible service that is fully managed by Synadia. It's the way of the future. Learn more at synadia.com/changelog. That's synadia.com/changelog.
Thanks again, Kyle, for coming on the show and talking to us all about slimming down your container images and different options for doing that and why it might be important, because that's just always a really interesting thing to see. Not only it's only a big tooling sector for containers, but also, hey, maybe this might be a good way to get better security benefits or even faster debugging by eliminating some of those, files and things that you don't need anymore.
Yeah, I thought that was really interesting, the security and the debugging,
Yeah, pieces that usually in a dev environment, you just throw everything in there. And then when you're in production, you're like, actually, what do I need now? For the outro of today's show, we are doing a segment called How Things Break. And I don't think I've had a consistent naming on any outros yet, but it's fun because we're just kind of mixing it up. And in today's outro, we're going to talk about a couple different outages, because while we're recording this on March 7th, we had two major outages this week on Meta/Instagram/Threads, and then also LinkedIn had a fairly large outage. And just a couple weeks ago, AT&T and Verizon had outages. And we're not going to throw any shade on any of these companies for having outages, because outages happen and the engineers behind them are doing their best. We don't want to ever imply that you're terrible at your jobs. If any of those people work at these companies and would like to come on the show and talk about one of these outages, we would love to talk to you, because those are, Adam and I's, some of our favorite things to talk about is when things break and you get paged, now what?
Yeah, hugs to ops for sure. But always, I think postmortems are the best way to learn how to be better at being an engineer, because it's always good to learn from the struggles that other people are going through, so you can make your stuff hardened and better and, more threat tolerant. So that way you can do better, So I think you should always have empathy for people, and you should always use it as a good story to make sure you're doing what you need to do. But I don't think you should ever throw shade or, look down on other people.
Yeah, it is definitely a difficult situation when you're on call and it's your job to fix it and the company is losing money or whatever. And there's a lot of stress there, and it's not fun.
You're making me sweat thinking about it. Just oh God.
But at the same time, sometimes those outages might be trickle-down effects of company initiatives, or laying people off, or causing people to come into the office, or downsizing in various ways. All of those things also can be affected. And it's not because the engineers are bad. Maybe the company didn't allow them to do their best work.
I do think that there's going to eventually be some sort of a correlation to the fact that we are asking people to do more with less. And the fact that so many people have been laid off and you've lost so much institutional knowledge and so much tribal knowledge that at some point that's going to come back to bite us. How many times have you tried to make a tweet on Twitter and it said, hey, do you want to save this into your draft? Because it's
sorry,
broken.
I can't do that right now.
And the fact that the engineers that used to work at Twitter, props to you for building something that could go through the type of reduction in force that it's gone through and still survived. That in itself is a testament to engineering. But I think a lot of things are very obviously broken because there's so many less engineers that have been working at these companies, and so many people have gotten laid off. I think we're going to continue to see outages until we care more about the people that are building them.
and running it and maintain it. And that's all, like, that's kind of this show, right? We want to talk about that other side of it. It's like, hey, the software development life cycle is like 90% running it and writing it is a very important part, and architecting is a very important part, but like the tail end of what software does is super critical.
Not just that, but it's a whole process. You need good and diverse opinions to build it and to design it. Then you have to build it. Then you have to go through testing. Like, this is like a whole process. So you can't make rash decisions halfway in a process, or, you know what I mean? Like, you need those people to be there to follow along. What if they've designed it in a certain way and then you've lost all that like experience, you know?
And all that context changes over time too, where it's like, as you hit scaling milestones of, oh, we need to do more stuff now because we have more users, you know, you have to sometimes re-architect it, and you have to split up single point databases into highly scalable multiple endpoints, or read writes, replicas. That sort of stuff all happens at different stages. And the thing that got you your first 1,000 users or 10,000 users may not get you to 100,000 or 1,000,000.
I read this book about data intensive applications, building data intensive applications, and they talked about Twitter's first algorithm, and then how they had to scale when they got celebrities and like mega users, you know, and how the algorithms had to be different. And like, we always talk about best practices, right? And we all want to follow those best practices, but sometimes there are trade-offs that you have to make, and you don't know why they made that trade-off if you weren't in that room, or if there was no context given to you, right? So every time we lose a ton of people, or the first people that built it, or, you know, we go through those cycles. It's one thing to go through cycles eventually, like over time. And it's another thing to lose like a huge chunk of the, like, who built it and kept it up for so long. Like, so many SREs were like fired and like laid off. And dude, like, SREs, that's a hard job. That's not something you learn overnight. That is a process to get to that level of knowledge and being able to keep things like available, you know? And it's just like, we should treat engineers better. It's a hard job, and we're all in it together. And I hope that we get to learn from these things, you know?
Yeah. And before started, rejoining and starting and Ship It podcast again, I was last year planning on doing a podcast all about outages and talking about how things fail. And I bought a domain for it and all this stuff. And then I realized there was other podcasts that already existed that talked about it and that they were great and stuff.
But I think we should do more of those, because I think that's how you learn. You learn from your mistakes.
Again, if anyone part of these outages wants to come talk about their major outage or something that happens, we would love to talk to you about it and all learn together from that, because those are super important.
Seriously, I love postmortems. I love reading them.
That's the last link for the show today. Is Kaggy, which is a search engine, had a postmortem, and they actually had a great write-up. They had an outage for almost 7 hours, which is a lot if you've ever been under pressure for being on call. And I don't know why their main link actually is gone. It's 404s for me now, but thanks to the Wayback Machine, we can still get to what was in the postmortem. And
I think they did such a good job for such a small company. Their investigation was like amazing. They did such a good job of pointing out like what went wrong, what could have gone better. Like, I think that's how you make better software, and you make sure things don't continue to happen, you know?
And one thing I really appreciate in this postmortem is the fact that they talked about all the things that they thought were the problem and didn't end up being the problem. Because they're like, oh, at first we started rolling out new instances with more memory. We chased that tail for a little while of like, it might be this, because this is the only change we did recently. Maybe it's that. And then they start rolling it back and like, no, maybe it's this, provider. Maybe we'll restart these instances. All of that stuff kept leading them to like, not the right solution. And they call that out in the postmortem, because that does take time. That investigation, all of those things is looking at what changed. How do we revert it?
But I think that's like so important. Like, everybody has a process. No matter what industry you're in, there's a process in how you work, right? And when you're like new to engineering, the process of like, hey, how do you take a on-call moment and how do you go through the process of figuring out the problem? That's like so important. Like, so many people can learn from the fact that they had a process. Like, maybe there's good things that you can take from their process that you can implement in your process, or maybe it's a good starting point if you don't already have a process. But that's how we grow,
And for me, like, pair programming is a great tactic for like learning how to pair things, but pair debugging is the thing that has let me grow more in my career than anything else.
Oh my God. My brain grows like 5 different, like, if you want to know how to scale junior engineers, that's how you do it. Even if they're not saying anything, you guys could both be working in silent and they can be working on what they're working, and they're just watching you.
I still remember like the first time I actually saw someone do strace in production on a Linux host, and I'm like, how did you do that? And they're like, oh, well, here's the process. I attached, I found this. I was like, what? Like, that's possible? And
it's mind blowing. I feel like people don't realize when you're new, there's so many things you don't know. But when they're writing documentation or they're writing out processes or designs, they're writing from an area of having all this contextual knowledge, right? The only way things are going to get better. That's why mentorship is important, right? So senior people realize how hard it is to start, and they remember the problems that you go through and the struggles you go through, and then you're up leveling those junior people. Like that's why it's this great two-way relationship that we forget about. We think that only the mentee grows in these relationships, and that's not true.
Going through those processes, it helps you understand. Like when I asked my coworker, was like, they were doing S-trace, I'm like, how did you know to look there? And they're like, well, I've seen an outage that looked kind of like that in the past. And it's like, these outages give off vibes that you just kind of get this, oh, you know what? This feels like the other one. So I'm going to try that direction first. And that's where we're going to start. And that you have to learn some of that. You have to experience some of it yourself. But being able to, once I saw that the next time in a ticket, I'm like, oh, you know what? Like this probably might be the thing that they told me before. Let me try their steps and see if it gets me a similar conclusion.
But that process is going to teach you so many things that you would not have learned on your own. You're going to just bang your head against the wall for forever, Well,
you don't even know what to search for, right? Like you don't know what you don't know. And there's no way that I can Google search a solution if it's completely opaque and not within my, toolbox of like, I can rely on this thing to do that problem, solve the problem. It's not going to happen. In the CAGI postmortem, they call out a couple paragraphs further down. I was just going to read some snippets of it where they say that to this day, we've yet to exceed 50% load capacity on their single core database server. They had the cheapest GCP database. And like, we never went over 50%. So we're probably fine. And the next paragraph, we then took steps to identify bad actors. And we found that accounts created within 24 hours had over 60,000 searches performed in a short period of time. And in this case, it was one of those situations where it was like, oh, it wasn't something that changed. It wasn't the obvious, well, just revert the Git commits or roll back the machines or whatever it is. It's like, actually, because we weren't checking or validating what users could do, they did whatever they thought was available. And they could do 60,000 searches in a short period of time. And obviously other things led to this, where it was like doing those searches was adding writes to the database, which was causing other slowness. And so their connection pools were, basically disappearing as soon as the machine would come up. But I really appreciated that as a postmortem where they walk through all the steps, they show all the debugging. At the end of the day, it's like we were down for 7 hours because a user kind of took down everyone, and we didn't check for that, and we didn't know that someone would even try that. And if I've learned anything in my time, is users will try anything that is available to them, even if it's not documented.
I also think that like for a company that I had never heard of, search engine, their postmortem was so detailed and wonderful.
Yeah, it was really good. And I wouldn't have known about it if it didn't bubble up into, my feeds of like, oh, this was an outage. I'm like, what's going on? And it didn't affect me, but I can appreciate a good postmortem, especially a publicly written one.
It's hard to talk about your mistakes in public, but also like, I think user endpoints and like database connections is such like an underrated issue that people should look for. Like, I feel like nobody ever thinks about that. And it's like it can be such an issue with databases, especially when you're like letting users like the way that they connect to it. So I think that's something that a lot of people will learn from, because it's not one of those things that are talked about a lot. So I'm really glad that they wrote about it.
Yeah, when basically every application is an API in front of a database, you're like, oh, what happens when the database does something? And like your database choices matter and your schema matters and all that stuff.
Well, like data modeling is such an underrated skill, right? And just the fact of like, I think people don't fully understand databases. They know that they want to dump stuff in databases. They know that databases exist, but I think there's a lot of knowledge on like how to interact with the database that is not very common. So I think problems like this, like it's amazing how you can like create your own problems, when it comes to your database. And like that's the worst thing to like, not worst thing, but like it's so hard when you like either like take a database down or you don't have a redundancy policy. Like data is so important to products, like it could be your user data. It could be data that you're tracking things. And like, what do you do if you accidentally take down your own stuff because you weren't thinking about that,
All right. Well, thank you so much for listening to the show. And again, if you would like to be on the show or have a topic to suggest, please reach out to us. We are shipit@changelog.com. You can just go ahead and email us. Otto and I both get them. We'll reply at some point next week. For us, it's a little busy, but by the time you hear this, we'll be getting over that. I don't know what the next show will be, but but I know we have a couple good ones lined up. And so we'll have about a month of various shows, and I can't wait to talk to everyone else and share all the great context on like how people run infrastructure, especially social media accounts. There's some platform engineering coming up. There's a little bit more container stuff.
I'm really excited about the Mastodon and Blue Sky, because like Mastodon, I felt like exposed a lot of people to like running their own servers. Like even if you've been in tech, maybe you hadn't run your own server before, and just like the good and the bad and the ugly that we learned from those like situations and the like exodus of Twitter. And then you come with this completely really different version of Blue Sky, you know, and then like Blue Sky was so much fun. And I think we've all interacted with Paul at some point, you know, on there, because at first it was so small, you know, like it was like getting into like the cool club, and it was like such a welcoming community. And then like to go and meet Paul and to hear like, hey, what was it like when you first started building this? Like, that's going to be so fun. And like, how has it changed since it's grown and matured, you know?
And now that it's completely open for people to sign up, all of those things are really interesting. And to your point of like, a lot of people don't run their own data or don't run their own servers. No one ever talked about the responsibility aspect of when you own a server and database. Yeah, like, and then you are responsible.
I think Mastodon, everybody was so excited about it, which makes me a little sad because I feel like it didn't get a full shot, you know? But I think we were all like, we're so busy. How are we going to run our own servers? And we are like, thank God Blue Sky came out, because like sometimes we were just like, we don't know if we can moderate. Like, I think it's funny because we're always like, we want to do all of our own stuff and like not be governed, and we want to have our own things. And then you're like, okay, wait, this is too much responsibility, you know? So it was really interesting how that kind of like cycled through. Like at first people were so excited about their own instances, and then like you could see like halfway through they were like, can I jump on yours? Like, and then Blue Sky, they're like, okay, this does all the cool things that we wanted from Mastodon with less responsibility. Like, you know?
I have all my own biases on Mastodon and Blue Sky and Twitter. But yeah,
I want to hear all of them.
I have plenty of blog posts and YouTube videos already out there about both of them. So if you're very interested, you could find them. But yes, at the very least, I am still interested and love talking about the infrastructure and how the architecture of both impact what people can and can't do with the systems, and how portable they are and how they interact with each other, and even the protocols of ActivityPub versus @ those things are really cool just to see that design impacts how the rest of it works and what people can and cannot do.
Also, it's a really fun learning opportunity. Like, it's one thing to build your own server to test, and it's another thing to actually have people use it and interact with it. And you know what I mean? So I think that's like, these are all really fun, like learning opportunities also.
Yeah, for sure. So thank you so much, Autumn, for joining again. And this was a great talk, and we will talk to you all again soon.
3, 2, 1.
Thanks for listening to Ship It with Justin Garrison and Autumn Nash. Subscribe now if you haven't already. Head to shipit.show for all the ways, or just search for Ship It wherever you get your podcasts. You'll find us. Thanks once again to our partners at Fly.io, to the mysterious Breakmaster Cylinder for these dope beats.
Oh yeah, my pleasure.
And to Sentry. Use code CHANGELOG when you sign up and save $100 off their team plan. That's all for now, but come back next week when we continue discussing everything that happens after Git Push.